Today we're talking about power and how to pay for it. Okay? So after this, you'll be able to solve. I'm giving you one more formula. You might want to have on your cheat sheet for the test all the formulas and make sure that they are correct. Okay, so you're going to be able to solve for power using P equals IV, and you're also going to be able to determine the yearly cost of an appliance. And who do we pay this to? Manitoba Hydro. Why is it called Manitoba Hydro?
Because we're in Manitoba.
Because we're in Manitoba and we use water.
Yes.
We use water. Hydroelectricity comes from the Greek word hydra, meaning water. This? I don't know. That's a good question.
So where does it use water?
They don't use. I don't think they use as much. I don't know how Alberta provides their power. Okay, you have a sheet. You should follow along and fill in some blanks. Here's something that I do in grade 11 and 12 physics. It's called formula derivation. Have you ever wondered where formulas come from? Okay, it's basically math. So, do you remember? Oh, power is defined as energy divided by time. That's what power is. And actually, there is a unit in grade 12 physics all about power. So this is the introduction to that. Power is defined as energy divided by time. Power, P, is E, energy, divided by time. Remember this formula, E equals QV?
No.
Hopefully you do. So this E and that E are the same. What does QV? Q is charge, V is? It's Q times V, yes. Q times V. So, can I take Q times V and replace that E?
No.
The answer is yes.
Oh, yes, so.
And it says so right there. So replace the E in the formula with QV. So P equals QV over T. We're not done. We're not done. Do you remember that I is equal to Q over T? So this Q over T can be replaced with I, and you get the boxed in formula P equals IV. That's the one you need to remember. I just showed you probably your first formula derivation. We came up with a new formula based on old ones. Power is equal to I times V. I won't expect you to do that on the test. That's just sort of an experience for you to have. Power is measured in watts, named after James Watt. He's got good hair. It's all about the hair. No.
Looks like you were getting your cut.
I couldn't possibly be that much of a scientist. I don't have as good a hair as these guys. When you replace a light bulb and you put in a 60-watt light bulb, that watt, that guy, James Watt, he's the guy that figured out how to make the steam engine actually practical. And it provided power. Okay, hey, let's jump right to the word problems. Now remember, we've done lots of word problems up to now. You should know the steps already. What are the steps? Write down what you know and figure out what you don't know and then show all your work, right? Okay, so let's practice this again. How much power? We are solving for P. P is our question mark. Is required for a can opener when it uses 120 V. 120 V, Lane, that is the voltage, 120. And draws 2.2 amps of current. What's the letter for current? I. Good. 2.2. So, our new friend, our new formula for power is P equals I times V. So we're going to write the formula. P equals I. If you want to put the little multiply in, you can. You don't need to. (2.2) times 120 264, thank you so much. 264 what? Watts. Big W. 264 watts. That's how much power a can opener takes. 264 watts. That seems like a lot of power. But it's cutting metal, right? So, yeah. You're going to be able to do this today. You're going to be able to figure out how much power. There's a few devices around the room that you're going to be able to figure out how much power they need. Let's look at the second one here. Who has a TV in their house? That's what I thought. A TV in your house is plugged in so that it receives 120 volts. Standard household voltage is 120 volts. Do you know what? Do you know what these things do? Don't say it's a charger. I'm talking about this thing here.
Power from the outlet into there and it's changing this one.
It changes the voltage, exactly. Standard household is 120 volts. Some things don't need 120 volts, so you need this kind of thing to change it.
So
Lots of things at home have these, right?
So things would be charged faster if we have those big things.
Well, it would probably blow up actually, yeah.
So it would be charged.
There's other things like pencil sharpeners that don't have that little black box on the end, and they don't need a little transformer. They need 120 volts. Okay, so TV in your house is plugged in, so it receives 120 volts. If the current use is 1.1 amps, how much power is required? Again, write down what we know here. 120 volts. V is 120. You're going to see 120 a lot. If the current use is 1.1, how much power? I think you guys can all do this. Why do you say that, Tyler? Well, maybe you should learn now how to do it. Well, ask the question, man. I'm showing you how to do it. Do you not see that I'm showing you how to do it? And that's why you need to follow the steps. Write down what you know. Right? Well, what does 120 volts mean, Tyler? The V is 120.
Yeah.
And the current use is 1.1. What letter is for current? I. And it says how much power is required. So P is my question mark. And I'm going to write my formula. P equals I times V. And Tyler, what is the value for I? So you write 1.1. And what is the value for V? 120. And then you take your calculator and you multiply it. T's got the answer for me already.
It is 136.
136, 132 watts. 132 watts.
That's how I do it.
Yeah,
Okay, never mind.
it's simple, man.
Yeah, it is.
Pardon me? Well, I times V, that's a multiply, right? When it's something over something, that's divide. Right? That's divide. Okay, now, this energy is not free. In fact, I showed you, flip to the back page of your booklet. See, it's the second last page right here. What does that look, the very last side?
It looks like
It looks like an energy bill. Guess whose? How much power, how much energy did I use in my house last month?
$142.
Holy, I gotta cut back. Hydro costs money. You have to pay for how much energy you use. Okay, so you have to pay for how much energy you use. Now, Manitoba Hydro doesn't measure it in watts because the numbers would be ginormous. So they measure it in what's called a kilowatt hour. Kilowatt hour. Rather than joules. Do you have to write that in?
No.
The current cost is, and I think you can see that on my bill, is 7.381 cents per kilowatt hour. What do you think a kilowatt is?
It's 1,000 watts.
It's 1,000 watts. Well done, Tyler, right? Because the word kilo means 1,000, like kilometer, 1,000 meters. Kilogram, 1,000 grams. Kilowatt, 1,000 watts. Kilo means 1,000. A kilowatt hour is using 1,000 watts non-stop for an hour. That's a lot. How many people have their mom or their dad say, turn the lights out? You think, power grows on trees kind of thing? Yeah, I do that at home as well. Today, you're going to find out just how much leaving your light bulb actually costs. Your mom and dad aren't going to like it.
It's the opposite way of mine goes. That's what my parents show.
Oh, yeah? Okay. You could call this a formula. It's more like a steps. The cost is the power multiplied by the time multiplied by the unit cost. And where it says unit cost, it's always going to be the same number, Lane. It's always going to be 7.381. The unit cost is, in Manitoba, 7.381 cents. If you want to do it in dollars, you divide by 100. This is cents. In dollars, it's 0.07381. That number there. Okay? It's how much it costs. So today we're going to look at certain items in your home and try to figure out how much they cost to run. Here we go. You'll notice this is the same can opener that you just had, right? How much power is required for a can opener when it uses 120 volts and draws 2.2 amps of current? I think we did that answer already, did we not? You got 264, didn't you? Are you guys going along?
That is 0.626 kilowatts.
No, you should be on page 2, where it says how much power is required. See that right there on page 2? And you must convert to kilowatts. How do you convert to kilowatts? It says right there, Tyler. Divide by 1,000. Or if you prefer, move the decimal place. 1, 2, 3. You must convert to kilowatts.
But what if we have more than 1,000 kilowatts?
Well, then it's going to be like 1.6 kilowatts or something, right? If you had like 1,600 watts, it would be 1.6 kilowatts. So how much power is required for a can opener? And we use 120 volts and draws 2.2 amps current. We've converted to kilowatts. Now, how long do you run a can opener for? As long as it takes to open the can. Good answer. Estimate that time. Maybe 20 seconds, 30 seconds, something like that, right?
I usually manually.
Has anyone ever ran their can opener for an entire hour? Probably not. But to make the question simpler, if you ran your can opener for an entire hour, cost is power multiplied by time multiplied by unit cost. 0.264 kilowatts times 1. How come 1? 1 hour. We want it in hours. Times 7.381. Using your can opener costs you 1.948584 cents. No. 1.9 cents.
That's almost 2 cents. That's not a lot.
We've already done the 1,000. We've already done. That's running your can opener for an entire hour.
So yeah, really 2 cents. I know.
2 cents.
No,
2
it's
cents.
2 cents. You can't convert 2 cents.
Yes, you can. It would be.
Oh, what? You're gonna cut your dollar into quarters? Yeah.
Right? It's not $2. $0.02. Right? $0.02. 2 cents. Yeah. Again, for an entire hour. So if you use your can opener for 20 seconds, we're talking practically free. Practically free.
Mr. Bennett,
Yeah.
what would it cost to run
Well, we're going to find out.
Wait, Mr. Bennett, if we just used like that over electricity, like that was our electrical bill,
Yeah?
we wouldn't be able to pay that. We don't have things anymore.
True enough.
Right.
Let's do another one. You might have a 100-watt light bulb in your bedroom that you leave on and your mom and dad yell at you. Does it say that? What about a 100-watt light bulb? Yes, it does. Okay, so follow these steps for me because you're going to have to do this later today, Tyler. I'm showing you the steps. What about a 100-watt light bulb? Say you leave it on all night in your house. So, 100 watts is how many kilowatts? 0.1. How did I do that? No, I divided by 1,000. So your light bulb takes 0.1 kilowatts. The cost is power multiplied by the time. It says you leave it on all night. We're going to have to estimate.
12 hours.
All night, I'm going to say 12 hours. Just an estimate, right? Doesn't have to be 12. It could be 11.97. I don't care. It's an estimate. Estimate. I'll tell you. Say from 8 p.m. to 8 a.m. Let's say 12 hours. So, cost is power multiplied by time, multiplied by unit cost. What's the power? 0.1. What's the time? 12. What's the unit cost? 7.381 cents. Where does 7.381 cents come from?
Manitoba.
Manitoba Hydro says that's how much we charge you. It's always going to be that number.
Must be like run out of water and then they have to go through Great Lakes.
Yes. Always. Multiply it out. Leaving your light on all night long costs about 8.8 cents. Less than 10 cents.
It adds up.
Of course it does. 10 cents, if you did that every night for a week, well, that would be 9 times 7. That'd be $6.30. That's enough to buy a burger and fries.
8 cents. Sammy would know.
Oh, yeah, it wouldn't be dollars, it'd be cents. Thank you. It'd be 63 cents, wouldn't it? Still, that adds up, right, for a week.
You can live off one light bulb.
And if you do it, multiple light bulbs, then each one costs that, right? Does that make sense to you? What are the steps, Braden? Find the kilowatts by dividing by 1,000. Take your time, power, multiply by time, multiply by cost. Got it, Jamie? Okay. Does anyone have like a new washer or a new dryer or even a fridge with something like that on it?
I have new everything.
Yeah? Have you seen those on your appliances at home? Maybe? Okay. So this is called an Enter Guide label. It comes from the Government of Canada. When you go into a furniture store or appliance store, you will see these on there. These show the estimated amount of energy to be used in the year, because when people are buying a new appliance, they want to know how much is it going to cost me to run. Which one is more efficient? What does that mean? That doesn't use as much power. Okay, so these show the estimated amount of energy to be used in the year. To calculate the cost, multiply the number by the cost of electricity. So this particular appliance per year estimates to use 554 kilowatt hours. That's what you estimate it to use. No, yeah, per year. 554 kilowatt hours. If you multiply that, because we've already converted to kilowatts, okay? We've already multiplied by the time, and multiplied by 7.381 would be 4,089. But that's cents. Is it there on your sheet? $40.07. What kind of appliance do you think that is?
Fridge.
I think that this is actually a washing machine.
Yeah, it is.
Yeah. Is that what it said on it? Where does it say that?
It says that in the later question.
Oh, does it? Okay.
No, but it says in the later.
Oh, yeah. I think I found this online. I think it was a washing machine. So if you go in to a furniture store like Roof's and you're looking at a couple washers, which one do you want? You want one with a high number or a small number? Low number.
That's $40 a year.
Well, I know. It's not too bad, right? Now, this is an estimate. If you've got 47 people in your family, this number's going to, well, okay, maybe I exaggerated, 17. If you've got 6 people in your family, that number might be higher than if you've got 3, right? It's just an estimate. But it's a way to compare 2 different washers, right? Now, interestingly enough, later on that page there, I went online, and I found this data right here. According to the Government of Canada website, these are the average energy rating for washing machines for the years 1990 to 2010. So, in 1990, a washer used about 1,218 kilowatt hours. 7 years later, they became more efficient, 930. 4 years later, 905. Now in 2010, only 319.
Yeah, but was energy like was not a turbo hydro cheaper back then? It was
Well, that's true, right? That's true. It's not that much cheaper. So, in 20 years, the efficiency has done what? Well, the efficiency has gone up. They're using much less power, right? Like almost a quarter. Much less power. If you have a really old washing machine at home, you're using power that you don't really need to. But the difference is you have to do what? Go and buy a new washer. Do new washers, are they expensive?
No.
You know, they're not, $20. They're expensive, right? But in the long run, you might save money. Let's figure out how much. Maybe it's worthwhile buying a new washer. I bought a new dryer, by the way. It's awesome. Okay, so we're going to do another, Tyler, we're going to do another cost analysis here.
Okay.
What would the total cost be to a homeowner if they bought a new washer in 1990 and ran it for 20 years? Every year they use 1,218 kilowatt hours. I don't need to divide by 1,000. It's in kilowatts already. I don't need to multiply by any hours because it's that many hours for the entire year. So it's 1,218 times the cost, 8,990 cents. But I have to multiply that. That's $89.90 per year, or a total of $1,798.01.
That's still cheap as hell.
That's still not bad. So over 20 years, that washer used $1,700 of energy. Over 20 years. About $89 a year. Does that make sense? Or does it make dollars? Sometimes I make myself laugh.
Go in there. You don't want one here.
Okay, the price is made.
Ah, very good, Jace. The price has changed. It was probably a little bit cheaper, right? That's assuming that this cost was the same back in 1999. And you're right, it was probably a little bit less. Not a whole lot. Like, it might have been 5 cents a kilowatt hour. Like, it's not going to be like that much, right? It's not going to be going down that much. So, there's still going to be a cost. Now, the next part is, what if they bought a new one in 2010? How much per year is it going to cost? We're going to do the same thing except with 319. So we're going to take 319 times 7.381, and oh my goodness, something seems wrong here. Why is that the same number? Because Mr. Bennett made a mistake. That's what. Is that the number? So, the cost for 20 years of a washing machine has dropped quite a bit. Do you think it's worth buying a new washing machine? How much would you save a year in energy? If you're using the old one, you'd be using about $90 a year, right? New washing machine might cost you maybe $600-700. In about 7 or 8 years, you have saved enough in energy to pay off that washing machine. So it's a pretty good deal. Well, people tend not to buy new ones because the old one works fine, they want to get rid of it, right? I got a heck of a deal on my new dryer, so I got rid of it, and I managed to get rid of the old one for, I think, $100. And the guy helped me put the new one in, so it's like a heck of a deal for me.
Said that's also wrong.
What are you talking?
Because what do you think to put the dryer in all that?
That could be, yeah. Price going up. Okay, so we've done a cost analysis here. How's everybody feeling about this?
I'm gonna
Because right away I'm going to say, go and do some more. Let's have a quick look at my power bill first before we move on. We're going to get a little bit of time to work the right away. Okay, I didn't scan it. I should have done that. Tyler, let's just have a quick look at this energy bill in the back. Okay? Okay, so this is in December. It says electricity residential, right? Meter number, service from, so this is from November the 24th until December 24th. Basically the month of December. 30 days. The meter reading at the start was 8052. The meter reading at the end of the period was 9885.
Where are
And
you
said,
seeing this?
on the back page, Tyler.
I'm on the back.
Okay, right here. Right here. See? Okay, so I used 1,833 kilowatt hours. They multiplied, do you see the 7.381 cents? It's in dollars there, right? It's $135.29. What's that basic charge, 728, you think?
Oh,
What is that? No, the 7381 is per kilowatt hour. If I turned off my electricity at my house for an entire month, I went away for the month I didn't run anything, it would still cost me $7.28. Okay? Because Manitoba Hydro has to maintain the poles, they have to maintain the wires, they have to pay people. That's the cost of just getting the power to your home. You still have to pay for how much power you use. Okay, so that's just the basic charge. And then, of course, then there's the tax come on it. So I spent $161.09 on electricity. What's the next thing down? Natural gas. What's that for? That's to run that's my furnace, my heating, right? So some of you might have electric furnaces, and that would use electricity. Some of you might have gas furnaces, that's using gas, same company, and you can see the cost there.
What about them wood stove users?
There's also those, they're not on here.
Yeah, see all.
Yeah, they're not on there either. Some of you, I remember when I was a kid, we had a great big tank, literally, it was probably about this high, maybe 8 feet long, it was fuel oil. And once a year, this guy would come from the Shell, big tanker truck, they'd plug in and they'd put like thousands of gallons of oil in my basement. Great big tank, and then finally we got electric furnace. Those were the good old days. I have no idea. I know it wasn't very energy efficient.
I don't care.
This handout right here must be turned in as part of your portfolio. This handout that I'm handing you must be turned in 4 marks. It is part of your portfolio. Do you understand? You must hand this in. On Monday, I'll have to think about Monday. Did I get to everyone? Okay. Okay, come here, Yates. Sit down. Just hold your horses. I know, relax. Just come here. Okay. So, 16 marks, Lane. Must hand it in. There's still people from first rotations that haven't handed this in. I email their parents weekly. Hand it in. Don't make me grumpy. I can't say. For all questions, use the cost of 7.381 cents per kilowatt hour. In Mr. Bennett's class, there is a fan, there is a pencil sharpener, and there's a wireless speaker. Guys, listen for the instructions so that you don't say to me later, I don't know how to do this. What am I doing right now, Tyler? Telling you how to do it. Determine the power required to run that device. Determine the cost in dollars to run it for how many hours?
8.
Circle 8 hours. Lane, circle 8 hours. At a time. When it gets hot in here and I have to run the fan for 8 hours, how much does it cost? How much does it cost to run a pencil sharpener for 8 hours? How much does it cost to run the wireless speaker for 8 hours? Okay? Question number 4. Determine the difference that it costs in dollars. The difference, meaning you must subtract between using a 13-watt fluorescent bulb, you know those curly bulbs?
I like those ones.
And a 100-watt light bulb in your home. Assume that they are on for 4 hours per day for an entire year. How many days in a year? 365. 4 hours for 365 hours a day. Flip the page over. There's more to this. In your home, ladies, in your home, determine the cost to run at least 3 appliances. Examples: fridge, stove, washer, dryer, freezer, toaster oven, toaster, coffee maker, microwave, TV, stereo, computer.
Etc.
If you're lucky, there may be an enter guide sticker on the appliance, or you may have it with the instruction manual. Otherwise, listen, make assumptions, like how many hours per day they are used to calculate kilowatt hours per year. You have to assume how many hours is the fridge running. Well, pretty much 24. How many hours is that light on? Not 24. How many hours is your TV on? How many hours is your coffee maker on? That kind of stuff. There is an example there. Braden, just listen. Okay, I'll answer your question, because you're going to ask me this stuff right away. So follow along. Are you looking? Are you looking at the sheet? Yeah. Example, microwave has a rating of 100 watts. That's a pretty weak microwave, I'd say. I assume it's used at a maximum of 30 minutes per day. Where did I come up with 30 minutes? I assumed it. I came up with it. It's not going to be on the back of the microwave. I said in my house, the microwave is used 30 minutes a day. Per day for 365 days. So, I took 100 watts. Why do I divide by 1,000? Got to be in kilowatts. I converted 30 minutes to how many hours? 0.5. You see that laying on the sheet? Put your finger on 0.5. Why did I convert it to hours?
Because you're a nice guy.
No, I am, but no. It's got to be in hours. Got to be in hours. I took 0.1 is my kilowatts times half an hour, 0.5. Why did I multiply by 365, Lane?
Here.
Why did I multiply by 365, Lane? Because I'm using the microwave every day for a year. And I get 18.25 kilowatt hours. I multiply by the cost. And my microwave cost me $1.43 per year. Okay, so what do you have to do today? You got to figure out how much power on the speaker. Give me 30 more seconds. You got to figure out the power. Hang on. Power on the speaker, power on the fan, power on the pencil sharpener. Then you got to do the bottom question. Then you got to take it home and do this part. You must hand this in to get credit. You will not graduate unless I get this sheet. Go.
What if we could find our
Maybe.